Okay, so I welcome you to the very first class of probability theory and random process. Okay, um, this class will be an introduction class. So I'll start my presentation now. So will use PPTs to um, learn this subject. So even for this introduction class, I'll be using this PPTs. Okay, and yeah. So are you able to see my screen? I think so you're able to see my screen. I'll just open my PPT. I'll start with the first slide. Okay, so this is our first slide. So hope everyone is able to see this slide, right? Okay. So as you know, I've just given the title of the course, Probability Theory and Random Process. So this is an introduction lecture. You can also see the course code ECE 215. Okay, so this is the course code. You will be using this course code for any reference of this subject. So maybe for the purpose of exams or any official reference to the subject, should be given. It should be the course code should be mentioned along with the subject name. Okay, okay, and then just given other details of the subject, it's the second year C section class, and it's academic year 2021, and it's the first semester. So we can see my name and my department affiliation. So I'll be handling this course for you for this semester. Okay. So now I'll give a brief outline of what this session is going to be. What is the discussion in this session is going to be. So first we'll set motivation and objective for studying this particular subject. Okay. So we are going to study probability and random process. So what is the motivation for this subject? So as an electrical engineer, what is the motivation, or electronics and communication engineer, what is the motivation for studying this subject? Okay, so and then we'll move on to the course curriculum, like syllabus, what is the textbook that we are going to use, and other resources, online resources, which will be useful for studying this course. Okay, and then we are going to see the learning process. Okay, so how the teaching learning process for this particular course will happen. So it is similar to all the other courses we are studying. And basically, the framework of the teaching learning process is the OBE framework, that is outcome based education framework. So I assume other teachers would have already given you a brief introduction about outcome-based education. Okay, so this is the framework under which all the teaching learning process happens here in our college. Okay, so and then we'll discuss about some simple rules for the online lecture, so that everyone gets benefited using this online lecture. Okay, so so one thing is, I want you to listen carefully to all the things I'm going to discuss in this lecture. So as the lecture progresses, you'll be asked to attempt a quiz. Okay, so the quiz will be based on what we discuss. So based on what I discuss with you, so the entire quiz will be based on that. So since this is an introduction class, I've kept the quiz, and I've kept very easy questions for the quiz. It's just based on the discussion. So as we move along in the course, we'll give some we'll discuss some more serious questions and more difficult problems in the quiz. Okay. My screen is completely occupied with this presentation. I don't know whether everyone is online, and I just come back to the normal mode and then I'll continue. Yeah. So, I think total 57. Okay, now the attendance is full, right? So yeah. So regarding attendance, the attendance will be taken at random points during the lecture. Okay, so please be attentive. Please be sincere for the class. So okay, now I think 57 people have logged in. So I'll take I'll take one attendance now. Okay. Okay. So so I just want to hear from some of you. So uh, I kept all the mics muted. Okay, so who is the class representative?
Sir?
So so you're the class representative.
Yes, sir.
I just wanted to get a feedback whether my video is available or not. So okay, so you're able to see my face, right?
Yes, sir.
Okay, okay. So yeah, okay. So just you keep your mic unmuted, okay, so that any feedback I can get from you.
Okay, sir.
Okay. Okay, so now again I'll go back to my slide. Okay, so again coming back to our presentation. So here we are seeing so why study probability and random process? So what is the motivation for studying probability and random process? Okay, so one thing is if you observe around us, so randomness is everywhere around us. Okay, so I have given some examples. Say for example, temperature and pressure, biological evolution, so reliable electrical communication. Okay, so buildings and structures, so finance and data science and machine learning. So these are some example areas or example domains where we can see randomness. Okay, so for example, when we consider temperature and pressure, okay, so the underlying phenomenon is the random motion of atoms and molecules. Okay, so because of the random motions of atoms and molecules, the overall random motion gives rise to temperature and pressure. So pressure is the random motion of air molecules. Temperature again is the random motion of any molecules in a solid material. Okay. So then if you consider biological evolution, so how living beings evolve. So again, biological evolution is the result of random mutations in the genetic material. So every cell has a DNA, you know about DNA and genetic material, and you know about when a biological being or a living cell reproduces, when a living cell reproduces and grows, so the genetic material also gets copied. So in this process, there are some errors that occur in the genetic material, which are called mutations. Okay, so these random mutations, which accumulate over a period of time, give rise to new kind of living beings. Okay, so this is known as biological evolution. And then when you come to communication, so just a very a familiar example. So communication systems. So on a daily basis we use communication systems like our cell phones, say satellite communication. Say we have direct to home television. Okay, so these are all communication channels, and in order to transfer information from one place to another, we have to understand a basic phenomenon which is known as electrical noise. Okay, so electrical noise is inherently present in all the devices and all the communication channels. So if we want to reliably communicate information from one point to another, we should understand this particular what is called phenomenon, which is electrical noise. So unless and until we don't understand and control electrical noise, we will not be able to reliably communicate from one point to another. Okay, so electrical noise is a random process, which we can observe in our daily lives. Okay, so again, when we see buildings and structures, so we want to design reliable buildings and reliable structures like bridges, structures like dams. Okay, so this is the domain of civil engineering. So even in civil engineering, we need to account for random nature of the forces of nature. Okay, so the random character of the forces of nature. Say, for example, the wind direction will be very random. So suppose if you are constructing a bridge. Okay, so you cannot assume that the wind will always blow from one direction, and you have to design the bridge. You have to design the bridge so that it can withstand the forces of wind from any direction. Okay, so say for example, if you consider designing of a dam, we have to consider the rainfall patterns. We have to consider how much water storage it has to withstand. Okay, so all these are random underlying phenomenon which we have to consider in the design of all these structures. Okay, so when we come to finance, so there is this basic requirement of economic risk management. Okay, so in the face of randomly fluctuating prices, okay, so prices of commodities or prices of stocks and bonds. Okay, so how to maintain a particular level of economic security. Okay, so how to maintain a particular so for example your bank balance. So how to maintain a particular balance even in the face of some random fluctuations. Okay, so suddenly you may incur some expenditures, pay some expenses. Okay, so these are random. So even in the face of this randomness, how to have some economic security. Okay, so this is a challenge in the financial domain. Okay, so this requires understanding of how the prices vary. Okay, so in the market, the prices of product vary randomly. Okay, so we have to have a understanding of this randomness of the prices, so that we will be successful in economic risk management. Okay, and then coming to the very recent example of data science and machine learning. Okay, so machine learning is basically acquiring some data. Means the machines have their sensors, though, so they acquire some data from the surroundings, and then over a period of time they learn. Okay, so they predict some patterns in the data, and then they learn. They come to some conclusions. So this gets stored inside the memory of the machine as a learning. Okay, um, so in that we have to understand the random nature of data. So what data that comes to the machine, that itself is random. So only when we understand the randomness in the data, we'll be able to predict some patterns in that. Okay, so this is again a very recent example. Okay, so whatever we have discussed now, these are random processes that are around us. Okay, so and then in this the random process which are very relevant to the electronics and communication engineer, I have highlighted in the blue color. Okay, so for example, temperature and pressure, communication, and the data science and machine learning. These are uh, these are systems that are directly designed by an electronics and communication engineer. Okay, so other things you might be involved, but these are the things that you'll be directly involved. Okay, so these are random processes. Okay, so when we want to understand something called a random process, so when we understand something, we should be able to quantify it. Okay, so quantification means we have to assign some numbers. Okay, so when we understand the process, we have to assign some numbers. Okay, so when to describe a particular process, we assign some numbers. Okay, so assigning numbers, the other word for that is mathematical modeling. Okay, so how do we model random processes? Okay, so that is what is the entire content of this subject. Okay, and So the mathematical modeling of a random phenomena is possible by making a basic framework which is known as probability theory. Okay, so probability theory is the fundamental step to understand these random processes. So I have given in the slide, it is a basic framework for the mathematical study of random phenomena. Okay, so probability, what is probability? Probability is a number which describes the likelihood of an event. Okay, so event can be anything. We can say the event can be rainfall, whether it will rain today. So the raining is an event. Okay, so okay, you can give some examples of other events. Okay, so we can consider the recent phenomena of this COVID-19. Okay, so the in this COVID-19 pandemic, we can define one particular event as, say, when will the disease end? Okay, when will the pandemic end? So that the day in which the pandemic ends, or the ending of the pandemic itself, is an event. Okay, so we can say, somebody says the pandemic will end by December 2020. Okay, so what is the likelihood of the pandemic ending by December 2020? So that is a probability. Okay, so we assign some number to understand the likelihood. Okay, so this is the basic framework. So we assign probability to particular events. Okay, so and then we move on to random variables, and then we move on to random processes. Okay, so this is the basic motivation. Okay, so the basic motivation for studying this subject is to design some engineering systems which can withstand this randomness. Okay, so how engineering systems would successfully perform in the face of uncertainties. Okay, so a simple word for randomness is uncertainty. Okay, so any engineering system we design, the system faces uncertainty. So even in the face of uncertainty, how to achieve the basic functions of the system. So that is what motivates us to study this probability and random processes. Okay, so hope you understood what we have discussed. Okay, so if you have any doubts in what we have discussed, you can just ask your questions in the chat. Okay, okay. So moving on to the next slide. So we'll discuss what is the syllabus of this course. Okay, and what is the lesson plan. Okay, so how we'll be completing the different lessons in the course. Okay, and then once discussing about the syllabus, we'll come to how how will the teaching learning process proceed based on the outcome based education framework. Okay, so we have some objectives at the end of the course. That is, after studying the entire course, the student is expected to acquire a particular set of skills. Okay, so we'll see what are those skills that are expected from the student, that is expected from you after learning this particular course. Okay, so we'll just have an overview of the syllabus of this course. Okay, so basically the syllabus consists of 5 units. Okay, so as you are aware of, even in other subjects, so this is the pattern we are following. So we have 5 units for this course. Okay, so the first 3 units. Okay, so the first 3 units basically focus on random variables, and then the later part, the 4th and the 5th unit, focus on random processes. So the 4th and 5th unit are the practically applied concepts. Okay, but before that, you have to build the theory, right? So you have to acquire the basic skills, and you have to have a basic understanding of all the probability related concepts. Okay, okay. So the first unit is titled probability and random variables. So you can see I'm just reading out the syllabus and then stressing some important points, so that while the course is in full swing, you can when we are discussing some particular topics, you can pay more attention to those topics. Okay, so you can give more importance. You can put some little bit more effort on some topics which are of practical interest. Okay, okay. So the first unit is probability and random variables. So in the first unit, the first part discusses about probability. Okay, so which you would have studied in your school days. Okay, so the basic probability, as you have studied, it is a likelihood number assigned to a particular event. So by observing some patterns, we collect the favorable number of events, and then we find how much of the percentage of the total number of event this favorable events occurs. Okay, so here we are going to see a little bit different definition of probability, which is known as relative frequency. Okay, so probability introduced through sets and relative frequency. Okay, so relative frequency is a little bit different approach. Okay, so when you apply engineering concepts to practical life, we'll be interpreting the probability number or the likelihood number using this relative frequency approach. Okay, okay, and then we have basic definitions which we use for defining probability. So experiments and sample spaces, and then we classify sample spaces discrete and continuous sample spaces. We define what is known as events, and then we move on to formal definition of probability and its axioms. Okay, so here we have an axiomatic approach to probability. Okay, so we have some basic rules. Okay, so basic laws. So there are three basic laws which you'll see in the um, upcoming sessions. Okay, so the three basic laws of probability are called axioms of probability. Okay, and then we'll see what is a mathematical model of an experiment. Okay, so again, the probability has a relative frequency. So this stresses upon the problem solving using the relative frequency approach. And then we'll see what is joint probability, and what is conditional probability, and then total probability. Okay, so once we have understood what is joint probability, conditional probability, and total probability, so using all the three concepts, we'll derive a theorem called Bayes' theorem. Okay, so the Bayes' theorem is a very important theorem, um, which which is the basis of statistical inference. Okay, so so basically, what we say is it predicts. The Bayes' theorem is used to predict a posteriority probabilities using a priori probabilities. Okay, so these words will be very new to you. Like what is a priori, what is a posteriori? That is, it predicts the probability of future events based on the past known probabilities. Okay, so Bayes' theorem is a very important theorem. When the as far as the first unit is concerned, this topic of Bayes' theorem is very important. Okay, so all the previous discussions lead to what is known as the Bayes' theorem. Okay, and then after Bayes' theorem, we discuss briefly about independent events. And then once, so up to the independent events, your probability concepts are means they're completely described. Okay, so and then the next topic is introduction to what is known as a random variable. Okay, so we define what is a random variable. So a random variable is again a number that is assigned to an event. Okay, so we'll discuss this in more detail, but for now, you assume that we define previously when we are discussing probability, we define events in a qualitative way. Okay, so whether it will rain today, okay, or say the events are assigned in a qualitative way. That is, say for example, you would have heard of ball picking experiment. Okay, so a bag contains balls of different colors. So red colored balls, yellow colored balls, so white colored balls. Okay, so these are events. Okay, so I describe the events in a qualitative way. So what is the likelihood of taking out a red colored ball? Okay, so all these are qualities. Okay, so when we assign numbers to the events, what we get is a random variable. Okay, so getting a red colored ball, I assign a number 1. Okay, so getting an yellow colored ball, I assign a number 3 or 5 or whatever I want. So, okay, so when we assign numbers to events, when we quantify them, what we get is a random variable. Okay, so this we'll see in more detail when we move into the subject. Okay, so then conditions for a function to be a random variable. Okay, so the random variable can be described by a mathematical function. Okay, so discrete and continuous and mixed random variables. Okay, so these are topics in random variables. So the first unit gives a brief introduction to what is a random variable. Okay, so now coming to the second unit, so it describes distribution and density functions and operation on one random variable. Okay, so distribution and density functions. So so at this point of time, it is it's a little bit difficult to describe what is distribution and density functions. Okay, so based on your school syllabus or based on what you would have studied in lower classes, so density and distribution are nothing but they are an advanced form of frequency tables. Okay, so you would have studied in say you would have studied some course in statistics, right? So suppose you conduct some test for a batch of 60 students, and then once the test is over, you collect students in particular mark ranges. Okay, so starting from this mark to this mark, how many students are there? Okay, so starting from say mark 50 to 60, how many students are there? From 60 to 70, how many students are there? 70 to 80, how many students are there? So you draw bar graphs. Okay, so which is also known as frequency tables. Okay, so the density and distribution functions are a little bit advanced form of the frequency tables. So within a particular range, how many people have obtained that particular marks? Okay, so similar to that, these are density functions which describe the random variables. Okay, so what is the probability that the particular random variable will take this much likelihood? Okay, so we'll see in more detail. Okay, so these are distribution and density functions for random variables, and then we discuss some important distribution and density functions. Okay, so there are numerous distribution and density functions in mathematics, but what we have mentioned here, these find practical application. Okay, so for example, binomial distribution, Poisson distribution, uniform distribution, Gaussian distribution, exponential distribution, Rayleigh distribution. Okay, so up to this, these are different distributions. Okay, so distributions can be assumed as a particular type of mathematical functions. Okay, so we see I think it's 6 different distribution functions. So in this the most important is the Gaussian distribution. Okay, so you can see binomial, Poisson, uniform, Gaussian, and exponential, and Rayleigh. Okay, so out of all the 6 distributions, the Gaussian distribution finds the most application. Okay, so almost in every industry, the Gaussian distribution finds application. Okay, so when you study, you should give more importance to that Gaussian distribution. Okay, and then finally we study what is known as a conditional distribution. Okay, so conditional distribution is again it is an advanced form of all these distributions, and then methods of defining a conditional event, conditional density, and its properties. So all these are related to the conditional distribution. Okay. And then coming to the next topic, it is operation on one random variable. So now we have established what is a random variable through all these distributions. Now we are going to study some operations on random variables. Okay. So when we say operations, so the single most operation is nothing but we are doing some mathematical operation. Okay. So say in statistics you would have done the operation of finding an average. Okay, so average is a mathematical operation. So given a set of numbers, you are asked to find average. So you have, if you you have some steps to find the average. So add all the numbers, divide the numbers by the total number of entries. Okay, so that is the average. So this is an operation. Okay, so similar to that, here we define an operation called expectation. Okay, so here you mentioned in the syllabus it is mentioned expected value of a random variable. Okay, so expectation is an operation which is defined on a random variable. Okay, so here expectation involves just your basic integration. Okay, so the operation of integration defined for a random variable. Okay, and then we move on to function of a random variable, and then we define what is known as moments. Okay, so moments are also a kind of expectation. Okay, so the basic operation means the basic theme of operation on one random variable is expectation. Okay, so you remember this point. What operation we are going to do on a random variable is expectation. Okay, the same expectation is done in different forms. So that is what is the entire running theme of this chapter. Okay, okay. So expected value of a random variable, function of a random variable, moments about the origin, central moments, variance, and skew. So all these are different types of expectation operations. Okay, variance and skew, and then we have what is known as Chebyshev's inequality. so which puts some limit on the value of expectation. And then we have characteristic function, and then we have moment generating function, transformations of a random variable, monotonic transformations for a continuous random variable, non-monotonic transformations of continuous random variable, transformations of discrete random variables. Okay, so these transformations are these are the practical applications of random variables. Okay. Okay. So and then moving on to the third unit. Okay. So the third unit is just an extension of the second unit where we have studied single random variable. Now this takes you to multiple random variables. Okay. So here two or more random variables are coupled. Okay. So as we can couple two or more events. Okay. So say for example rainfall and say say crop growth. Okay. So which are related events. Okay. So there is rainfall and then we have growth of crops. So how these two events can be coupled together. So like that we can couple many events and then study those events mathematically. So the third unit stresses upon multiple random variables and operations. So here we have vector random variables, joint distribution function. Okay, so there are a lot of topics. So I'll just leave the topics for you to read. Okay, so these are a little bit complex to explain. And one important thing I want to stress is the important concept of the third unit is the central limit theorem. Okay, so I think you can see the topic here, central limit theorem. Okay, so this is the one concept that finds practical applications as far as the third unit is concerned. So the central limit theorem is used extensively in population studies. Okay, so the government conducts population surveys. Okay, so they conduct door-to-door surveys, like how many people are there in a family, how many people get educated, all those surveys. Okay, so we have a vast amount of data. Using that data, the governments come to some conclusions. Okay, and they do some predictions. Okay, so all these are done using the central limit theorem. Okay, so that is the essence of this chapter. So unit 3, the central limit theorem is the most important topic. Okay, so and then we move on to the next part of the third unit, operations on multiple random variables. So expected value of random variables, joint moments about the origin, jointly Gaussian random variables, two random variables. So it is just the extension of the multiple random variable case. Just we are taking the expectation operation to multiple random variables. So in the second unit, what we studied as expectation, so that operation is applied to multiple random variables. Okay. So now coming on to the fourth unit. Okay, so this unit introduces you to the topic of random processes. Okay, so random process is nothing but the time attribute is added to the random variable. Okay, so when a random variable occurs the attribute of time, what we get is a random process. Okay, so random process, as we discussed earlier in the previous slide, we saw some examples, right? So random motion of atoms and molecules, random mutations in the genetic material. So everything happens with respect to time, right? So these are random events which are located in time. So at different times, some event happens. Okay, so when we include the time axis and study these random variables, what we get is known as the random process. Okay, so and there are a lot of terms which describe random process with respect to time. Okay, so the fourth unit is the study of random processes. The fourth unit introduces you to random processes, and it involves the study of random process and their characterization in the time domain. Okay, so everything is done in time domain. Okay, so how the process varies in time. Okay, so now the fifth unit, it is also discussing about random processes, but in terms of frequencies. Okay, so basically any signal can be viewed in the time domain or in the frequency domain. Okay, so the fifth unit enables us to view the same random process in the frequency domain. Okay, so how to characterize a random phenomenon in the frequency domain. Okay, so the basic concept in the fifth unit is the power spectrum. Okay, so and all other related terms are descriptions of the power spectrum. Okay, And then the final topic of the fifth unit is characterizing linear systems. Okay, so when you design a particular system, okay, so the basic job of engineers is to design systems. Okay, it can be a communication system, it can be just a small sensor. Okay, it can be an instrumentation system. Okay, so all these are systems. So how these systems perform in the face of uncertainty. Okay, so when you feed some random signals into the system, what do the systems give us output? Okay, so that is the topic that we study in the fifth unit, final fifth unit. Okay, that is the final topic. So in that we study random signal response of a linear system, and then finally what we use is a Rice representation. Okay, so the Rice representation is is the name of a scientist. It's a technique to represent the linear systems and their random input and output signals. Okay? So the fifth unit is also practically most applied unit. Okay, so the concepts of the fifth unit are applied in many practical situations. Okay. So now moving on to the textbooks. Okay. So these are the prescribed textbooks for this course. Okay, so the first textbook is Peyton Z. Peebles Jr. Okay, so it's authored by Peyton Z. Peebles. So it's titled Probability, Random Variables, and Random Signal Principles. It's a fourth edition. It's a Tata McGraw-Hill publication. Okay, and then the next textbook I would suggest is Probability, Random Variables, and Stochastic Processes by Athanasios Popoulis and Unnikrishna Pillai. Okay, so both these are very standard textbooks. But the first book will be more readable for your level. So the first book is the first book is what I will suggest for beginners like you. Okay, so the second book, it is a little bit advanced. Okay, so so we'll use the second book when we come to the fourth and fifth chapters. Okay, so the concepts of fourth and fifth chapters, you can understand more clearly using the second book. Okay, so the first book is what you are going to follow for the first three chapters. Even for the fourth and fifth chapters, you can follow the first book, but you will not have more content in that. Okay, for the fourth and fifth chapters. Okay, so the first book is very important. Okay, and then I also shared some online resources. Okay, so you can see a website towardsdatascience.com. Okay, so this website contains it is actually a blog site. Okay, so if you just Google it, towardsdatascience.com, it is a blog where many people contribute. Okay, so people who are working in data science. Okay, so they contribute to this blog. So this blog is the main motivation for this blog is to um, describe more complex concept in a very simple language. Okay, using pictures, using examples. So whatever concepts we study in this course, so we'll be going in a more mathematical way. Okay, so but here you can find say the concepts are described in more simple language and mostly through pictures. Okay, so it'll be feeling comfortable when you understand concepts both mathematically as well as using simple language. Okay, so I advise you to I suggest you to go through this website so that you'll find the concepts you learn mathematically, you'll find more interesting way how they are described. Okay, so now coming on to outcome-based education, I think we have 5 more minutes. So I'll just go through this outcome-based education framework. The slides move very fast. Okay. So here we have outcome-based education where you're expected to acquire some skills. Okay. So OBE is a process that involves restructuring of curriculum, assessment, and reporting practices in education to quantitatively reflect the achievement of higher order learning. Okay. So basically what we are aiming at is higher order learning. Okay, so you can see learning of a subject happens through these 6 steps. Okay, so you have to, the basic step in learning a subject is remember some concepts. Okay, so next step is understanding some concepts and then applying those concepts and then analyzing those concepts. Okay, and then evaluating a particular stand or a decision. Okay, and then creating new knowledge. Okay, so these are the 6 steps through which any person learns a subject, any person masters a subject. Okay, so Okay, anyway, you can look up on this slide. I'll be sharing this presentation with you. So you can look up on the different levels of learning. Okay, so why I'm showing this levels of learning is, so our assessment pattern will be based on these levels of learning. Okay, so questions of remembering type you can identify which question is remembering type, which question is understanding type. Okay, so based on the level will be given marks. Okay, so why this OBE? Because of this accreditation and standardization in education, we are going for this outcome-based education. Okay, so only when we follow this OBE standards, your course will get accredited. So, what is the benefit of getting accredited? Your course will be recognized in an international market. Okay, so the degree you get will be recognized internationally. So that is the benefit of getting accredited. And getting accredited requires us to follow this outcome-based education framework. Okay. So finally, this is the most important slide. So we have a list of course outcomes. That is the list of skills the student is the student is expected to acquire. So first skill is calculate problem. So this is based on the different units. Okay. So you have 5 units. So after completion of each unit, you are expected to acquire these particular skills. Okay. And whether the student has acquired these skills will be evaluated, and it will be quantified at the final level. Okay, so at the end of your exams, the entire course will be evaluated for whether how many students have acquired the skill, to what degree each student has acquired this particular skills. It will be evaluated, and it will be reported as it will be reported as an attainment level. Okay, so it will be quantitatively reported. Okay, okay, so we can read up all these different skills. So the student should be able to calculate probabilities and conditional probabilities of events defined on a sample space. The student should be able to compute statistical averages of one random variable using probability, density, and distribution functions, and also transform random variables from one density to another. So you should be able to compute statistical averages. Okay, so that is the third unit. And then fourth unit, coming to fourth unit, determine stationarity and ergodicity. So these are various time domain characteristics of random process. We have to determine, you have to numerically, you should be able to numerically um, describe the stationarity and ergodicity of a random process. Okay, so these are technical terms which we'll be studying in more detail. And then finally, you have to you should be able to compute and sketch power spectrums of different random processes. Okay, so I think you would have got some introduction to program outcomes and uh, um, program specific outcomes, which lead to attainment of mission and vision of the institute. Okay, so all these are oriented towards acquiring some mission and vision, okay, which are stated in the institutes. You can look up those mission and vision statements in our college web page. Okay, yeah. Okay, so finally, some simple rules for the online class. Okay, so you'll have continuous assessment. Okay, so at the end of each lecture, you'll have some small quizzes. Okay, and so attempt those quizzes sincerely. Okay, so all the quiz marks will be added up. They will contribute to your final score. Okay, so please attend them sincerely. And then I advise you to solve problems. Okay, so basically we'll be solving end of the chapter problems. Okay, so this course requires mathematical thinking, so practice more problems. Okay, and then considering attendance, so please be available to the class as early as possible. Okay, so that you won't miss any topics. Okay, so attendance will be taken at many points during the class. Okay, and considering doubts. Okay, so if you have any doubts, um, you can discuss in the group mail. Okay, so we'll discuss all the doubts in the group mail. So if you start asking doubts in the chat box, it becomes crowded. Okay, so please ask doubts in the group mail. I'll also share my personal mail ID. Okay, I have not given here. Okay, so in the next session, I'll share my personal mail ID. You can ask your doubts using that mail ID. Okay, so in the classwork, I have shared a quiz for this session. Okay, so please attempt this that quiz. Okay, so now I'll complete my slides. Okay, so thank you for this session. Yeah, the representative.
Sir.
Yeah. Okay, I have shared a quiz. Okay, so I think I have given the time limit to 11. Okay, so I'll extend the quiz to. So now it's 11. So I'll extend the quiz to 1 o'clock. Okay. So are you able to see the quiz? So the quiz is due 11 p.m. Okay. So now I'll complete the class. So you just check the classwork. Okay, in the Google Classroom, in the classwork, I have shared a quiz. Okay. So please attempt the quiz by 1 p.m. Okay, so I'll change the time. Now I have given the due time at 11 p.m. Okay. So since you have one more class now, so you won't be able to attempt the quiz immediately. So after that class, you can attempt that quiz. Okay. 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 So shall we end this session? Okay. So please look up the quiz. I will just edit the quiz timing. Okay. The representative.
Sir.
Yes. So now I'll end the class. Hello.
Okay, sir.
Okay. So ask all your friends to attempt the quiz.
Okay, sir.
Yeah. So quiz is for 5 months. It's all objective type. Okay. Okay. So thank you for attending the class. We'll meet in the next session on Thursday.
Thank you.
Yeah. Thank you.